In this video, we'll take what we learned about cross products and feed it into a for loop and constantly reapply the cross product again and again to see what happens. Then I'll take it up a notch and add a sine wave animation to it all and generate a spring effect. So let's move on to the next basic concept. So this is basic concept number 2. So I take the cross product and I keep applying the cross product to the same point over and over and over iteratively, and this is the result that we get. And this is you'll find this very familiar if you watch that live stream. This is how we got that tornado motion, because of this swirlingness. So we start off with one point over here. We start at that point and we take the cross product of this point and we get the second point over here. And then we do this again and we take the cross product of that point and we get the third point over here. And we keep doing this again and again and again. So this is the second point, third point, fourth point. Let me zoom out. You can see that this is updating. I have this updated, the guide arrows and our little blue hand updating. So we keep taking the cross product over and over and over again. And what I want you to see or notice is that this is going in a circular motion. It's like when you get into a car and you keep turning right on the first intersection. Every first intersection you see, you're going to turn right. You're going to be going in a circle. And this is exactly what is happening. It's going in a circle, in a spiral. And another thing is that a couple of features we can control out of this setup is that we can control the two vectors that we feed into the cross product, which I've exposed as two parameters that I call the axes and the center. So those two vectors, the center would be this one over here, and the axes is what it rotates around, and that controls how this spirals. Let me get rid of the grid. I'm going to take these two parameters, which are the two nodes here that I've colored in pink, and I'm going to change the direction of the center. You can see it changes significantly. It springs up and down. We can change the look of this spiral very, very easily by tweaking these two parameters. And if I change the axes, it actually changes the orientation of the entire spiral. And let's take a look at what the cross product looks like. The center and the axes are fed into this cross product the same way that in the grid example, in the single grid example that I've shown in basic concept number 1. Let's go back here. The cross product has these axes, which is a vector that we feed in, which is this vector. It's spinning around. We're going to define a vector that we call the axes that this spiral will spin around. The center is a point right here, is the point right there where we start off with. So we have something to make relative. As you can see over here in this line, the position is subtracted. We're getting our second vector by subtracting the current position of the point on the spiral minus the center. So we have a relative vector, which is the same thing that I shown in the previous basic concept. Here, it wasn't enough to feed in the positional vector value right into the cross product. We had to subtract it with something in order to get this relative, these two relative red vectors, so that when we move this grid, we still get the correct perpendicular cross product value. So we always needed a relative vector relative to the grid. In this case, it's the grid. In the spiral example, we are being relative to the center point that I've exposed as a parameter. This center point right here. By applying the cross product again and again and again, over and over and over, it produces this spiral effect. So there's a lot of different things that you can do with the cross product. You can play around with to get different effects. Now, this is just a very simple example of what happens when I keep applying the cross product, that you end up getting a spiral, a turning, a circular motion, or a tornado motion is what I showed in the last previous live stream. And that brings us to the next basic concept. I took what we had in basic concept number 2 that had that repetitive cross product spiral, and I cleaned it up a bit. Added some keyframed animation to the center vector that was exposed as a parameter. I'm just going to reset this so I can show you. Now let's start off with the wireframe first, because the polywire is a little too thick. Now the two vectors I've exposed, I've named the two vectors center and axes. So let's take a look what happens when I tweak the center. I'm going to add some keyframed animations to one of the exposed parameters, the center vector, and we'll see the results. The quick doodle animation you see here is illustrating the red arrow as the center vector, and the keyframes that are animating on the screen is changing the y-axis value of the center vector. So you see the red arrow growing larger and shrinking down because we're changing the y value, and this causes a ripple effect into the spiral. The center vector you see on the screen is currently right on the origin, so the y value is 0, and this explains why we see a flat spiral. Change the position of the center. Okay, so the whole thing changes, and we already know that. But why is it changing? Well, the two vectors that we have is the center and the axes. Well, what I call the center and the axes. That's what it's all rotating. That's what this whole iterating cross product is rotating around. Now there's the center, there's the spring axis. Now I'm going to modify the spring axis because it's really close. And I really want to distinguish the two so you can actually see what's going on. I'll move it over here. So there's the axes, there's the center. Now what I want to do, I'm going to merge the axes and the center vector together. What I'm going to do here is I'm going to draw a line between the two so we can actually keep track where it is. There it is. And then I'm going to add some more lines. I'm going to add an origin point, and I'm going to connect all these. So we're going to get a triangle. 0 and 2, draw a line there. Points 1 and 2, draw a line there. So now we have our little triangle. So our two vectors is, so that is our center vector, and this one is our axis vector. So these two vectors, which I've drawn a triangle connecting them all, determines how the cross product is going to orient the whole spiral. Because I keep applying the cross product on the same point over and over and over again, advancing it forward in the direction of our perpendicular result. So the cross product will always give us a perpendicular result, and if we keep advancing it, we get that spiral look. You may start to recognize this triangle because I showed a similar example in the previous basic concept number 1 video on cross product and how the cross product vector of a polygon is perpendicular to the surface. The triangle you see here forms an invisible polygon, and our invisible triangle is facing the direction of the spiral. The surface is facing the same direction of the spiral. It's invisible because there really isn't any polygon or triangle, but once you have the two vectors that I keep talking about, you have the same properties. It's just much easier to picture the triangle or the square rather than just picturing the two vectors floating in the middle of nowhere. Once the first step of the spiral goes downwards, you start spiraling all the way down because the cross product keeps iterating the same downward motion. I want to tweak the center back and forth and just controls where it goes. Now let me change or tweak the axis vector. That's this point over here. Let me put this in the center. That way we have a better look at the whole thing. So now the widget's right directly on the dot. So by tweaking this, again, we get very small tweaks will generate very large results. This sort of changes where the orientation, it affects the orientation a lot more, but also controls how it spirals too. Like the stretching too, it can also control that. And when you combine the two, you can control where is it stretching, how is it stretching, and the orientation of the spiral as well. Okay, let me bring back the grid, and I used this to create a really spring animation. Okay, I'm going to position it so that it's facing downwards. Okay, put this back over here, place the render flag back onto my polywire. And what I did is on the center vector, I applied a sine wave. And I applied it up and down. Oops. I'm going to zero the other ones out. So I only applied a sine wave to, so this is the center vector. And I'm modifying this transform node, which is the vector, positional vector that I'm feeding into the cross product. The sine wave is over here. So what it's doing is I'm only modifying the y value of the center vector so that the spring would go up and down, up and down. Now let me play it for you. Let me zoom back. I'm just going to position this so we can see the entire spring. You can start to make out this part of the sine wave. So it goes down and then up, down, and then up, down. So that is the sine wave. Now what I wanted to show you is, let me remove this offset I did on the sine wave. Okay, and let me play it now. So you can see that it's flipping all the way up and down. It is going up and then all the way down. So it is doing a flip. Without that offset over here, it really makes a huge difference. Now, in order to explain this little sine wave I've put in here, this little formula I put in here, I'm going to come over to the side and do a little bit of side project here. Okay, let's start with the dot to simplify the whole thing. Turn on this. So that's the dot I'm adding. Let's add a transform node. And I'm going to apply that same sine wave function. I'm going to apply it to the y vector, a y-axis of this position. Now, I did add this variable in here for the change to manually tweak the speed in my center over here. In my center node over here, in the transform node. So there is a change speed over here, which is this one over here. So I'm feeding this change speed, or this parameter that I was manually tweaking, so I could control the speed of the spring animation, and I'm feeding it directly into the sine wave. Now, in our little rough draft of a smaller, simpler animation here, I'm not going to control the speed, just to simplify the problem a bit. This one. Okay, let's see what happens, because right now, this $F is the number of frames, is the current frame that we're playing on in the timeline. And that's driving the sine wave. When the frame changes, the sine wave changes as well. So the frame is actually, this frame is driving the sine wave. And I'm going to play the animation so you can see, you'll see this dot here and it'll be moving up and down. However, it's moving very slightly. So you can see that the numbers are changing when I'm on a different frame. Let me change the perspective. Okay, this should be a more clear view. Okay, there we go. This down here is 0 on the y-axis. This is 1 on the y-axis, and this is 2. And you can see that this dot is moving all the way to the second unit on the y-axis and coming all the way back down, passing the first unit, and then it's actually bouncing on the bottom on the zero value of the y-axis. It's just that I run it on frames at the end here. What I wanted you to understand is that the sine wave will return a value between 0 and 1. However, if you look over here in my translate, where I have my sine wave formula, I've added 1 right over here. So I'm offsetting the entire sine wave by 1 more unit. Now what happens if I remove this +1? Let's take a look. So you see that this dot is moving beyond below 0. So I actually have to adjust my viewport now. Now the whole thing is shifted downwards because I've removed my +1 offset. Now my dot is actually going up to 1, bouncing on 1, moving all the way down past the 0 and hitting -1. And again, I apologize. I'm running out of frames. Let me increase my number of frames. So we've shifted it all the way down. And this really helps with that spring animation because I'm able to spring it in the positive axes. What I really wanted to take away from this is that the growing, the increasing value and decreasing value of the sine wave. This is what I really wanted out of the sine wave, and feed that increasing and decreasing momentum into my cross product, into my spiraling spring effect of a cross product. However, I only wanted the positive values. So that's why I needed this +1 here, because I only wanted the positive values. I'm going to enter that in. And you'll see that this returns. So this returns to the 0 to into the range of 0 to 2 on the y-axis. It's all positive values. That's what I really wanted to get out of the sine wave. That increasing effect and decreasing effect. But because the natural values of the sine wave gives me a +1 value to a -1 value, that's not what I really wanted out of it. I only wanted that increasing and decreasing momentum without the negative values. Adding 1 shifts it all the way up, and this is perfect. This is what I need for my spring effect. So let me go back to this spring animation, and let's go back to this center. Now you'll see this center here. This spring is animated using this sine function that's fed into the center vector. One of the 2 vectors for the input of the cross product that I call center. I'm feeding in the sine wave, and this is without the +1. So this is without the offset adjustment. Now there is a speed variable here, but that's just to increase it and speed things up a notch. Otherwise it would be really, really slow. Okay, so you can see that it goes up and down in the positive. I'm going to put this in the front view so we can see it like this. Okay. So this spring is now moving in the negative, positive. So it's bouncing between the positive and negative values on the y-axis. And this is not what I wanted. I mean, this may be what you want for your effect, but all I wanted this spring effect to be doing was bouncing up and down here, to bounce on the ground level and then bounce back down. So I don't want it to travel between the positive and negative values. And in order to achieve that effect, all I did was add 1 over here into the sine wave function, and that will shift everything. So you might be wondering, why am I offsetting the sine wave by 1 by adding +1 to it, but the spring is still bouncing in the negative area? Why isn't it bouncing in the positive area? This is the origin of the world space, the 0, 0, 0 position. This is the axis vector, which is one of the 2 vectors that I've exposed out as a parameter so you can tweak. This is the first point in the whole spiral that kickstarts the whole for loop, repeatedly applying the cross product, but you gotta start somewhere in the for loop. So this is the first point I picked. All these points are fixed points, they don't move. The center point is one of the 2 vectors that I've exposed out for tweaking, and it's also the one with the keyframe sine wave animation attached to it. But we need a relative vector to feed into the cross product. So as I mentioned before, you can't just take the position of the center vector and stick it into the cross product. You need to subtract another point to make it relative to the respective geometry. And in this case, we're trying to create a spiral. So that'll be the first point that kickstarts the Foreach loop before we start repeatedly applying the cross product over and over again. The relative vector is the at P minus center, which is the moving dot here. Why is this moving? The center is moving because we put a keyframe sine wave animation on it. But why is this relative vector moving as well? The relative vector is calculated by subtracting at P from center, the at P minus center. So if the center changes, this relative vector changes too. And I hope you see when the center heads up, the spiral heads downwards. This is the reason why the +1 offset in our sine wave causes the opposite direction in our spring effect. In the next video, I continue on with the cross product, but this time we'll use the cross product to create a left and right detection system. And then in the next example after that, I use this left and right detection system to rotate chairs so it all faces the same object in the concert hall. Thanks for watching and sticking to the end.